My name is Robert Miller. I'm from Tufts Medical Center. I co-lead the GIS working group with Andrew Williams, and we're going to give a quick update here on what we've been up to. The overall goal of the working group is, in its simplest form, just geospatial data integration. What we've been imagining is an optional GIS module that sits alongside the CDM rather than within it. There's two general categories of functionality: either bringing data in as in a person level attribute, or pulling data out in just some geospatial format, like a region level attribute. And the potential scope is massive of what we're doing. We've been at it for a while, and we're prioritizing what we're developing based on the use cases we have and the timelines we have. But we haven't really drawn any lines in the sand of where we're going to stop at this point. So we're just sort of going by what's needed in the short term. And the focus has been on the foundations to make this flexible and extensible, and sort of not go down a dead end road and be able to and not be able to support international use cases or things we haven't seen up to this point. Thus far, the biggest piece that we have been working on was the schema. So there's a schema to represent any geospatial data we've come across thus far in a common format, almost like a geospatial CDM. That way we can leverage the same functionality based on, it doesn't matter what data set you have in there, whether it's EPA data or census data or whatever. And that borrows some things from OMOP design. The actual attribute tables look nearly identical to the measurement table. The same sort of concepts and metadata around that. If you wanted to check that out, that's in the GitHub repo along with the rest of this here. We did some vertical sprints to test the schema and implementation strategies, which in turn was a cyclical thing where we went back and changed some stuff. And most recently, there's been my colleague Jake Gilbert has been pushing Docker on us. It's been a very good thing. There's a deployable Docker infrastructure now that has two main pieces. One's a PostGIS instance, which you stand up locally at your site to do the geocoding. We're going to store that schema that was mentioned here and any sort of geospatial functions you need to use, like points and polygons to show how patients relate to regions, things like that. So that is the entity that you stand up next to your OMOP instance. And there's a separate Docker that's basically just our engine, script loaders, which handles everything in the pipeline of, like standing up the tables or going to get the data, translating it, whatever you need to do. But again, it's with a focus on being flexible. So we, at this point, could really just put whatever kind of scripts you want in there and just determine those pipelines with the configuration that you have. And recently just reworked the GitHub repo to make it a lot more intuitive. It was a little hard to understand. And so with the structure with Docker and how flexible it is, and now with the structure of GitHub, we're hoping that it'll be easier for people to contribute to the code base. What we're up to right now is refining those Docker deployments to be comprehensive and customizable. So the idea would be that you could just have like a one-click go for a specific use case like N3C or whatever you want to snap the tables, get the data you need to do geocoding, use that geocoded data to go get your attribute data, and then submit it or whatever you need to do at that point. Specifically with N3C, we're working with them in particular EPA to work to get the environmental social determinant data into N3C. That is a work in progress. We just started with the RU Institute to potentially contribute for a strategy for preserving privacy. On the next slide, I'm talking about a little bit that issue. Conversion of geospatial data sets into that common format, just building up that code base so that we can keep adding new data sets that will either be persisted as code or as the actual data to be determined, but just sort of adding those as we go. And that's the easy thing to contribute to as just somebody from the outside. And working on the remaining challenges. So the challenges, these are just some of them, the ones that came to mind as coming through here. Just want to focus on this section the most to entice the problem solvers in the audience to potentially join our effort. So this is fundamentally a different kind of data we're talking about. It's not person-centric, which sounds not as significant as it is, but if you have a data set like a environmental air quality sensor data, and you're trying to attribute that to a person, you can do that in a million different ways. You can say the closest, the average of the 3, or you're doing some interpolation, and there's this just extra disconnect that you have to account for. Measurements they aren't always, I should say, in the same format where you could have multiple values on the same row, or multiple qualifiers or methods, or durations, sample durations, or margins of error, all sorts of different stuff that you don't normally see in clinical data. Privacy preserving strategies is a big one. We can't leverage a lot of the APIs that are out there for geocoding, for instance, because you'd be sending the patient information away off the site. So everything we're doing is locally deployed. You're pulling rather than pushing. You go get the data you need to geocode and do it locally, or anything we need to do that has that level of PHI in it. And this new one of preventing re-identification when you're attributed to public data, if we have daily level sensor data, and this person had 10 values in it, you can probably narrow down exactly where they were if you have access to that public data. So a method or methods or strategy for being able to obfuscate that in some way, to be able to have that in a public repository like N3C and not be worried about re-identification. And that is where RU is coming in here, or just starting. Vocabularies are a big issue. A lot of the data sets don't have unique identifiers like we're used to in clinical data. They're either missing or they're too general. There's a code for PM 2.5, let's say, but there's probably not a code for PM 2.5 collected in a certain way with a certain method and duration and type of sensor, stuff like that. And the mapping between vocabularies for something like social determinants is probably a better example of like poverty and how that persists in social determinants or census or SVI or whatever. Being able to map between those, we have not come across yet. And integration with OHDSI in general. One of the bigger issues recently is how can we leverage OHDSI tools with data at the person level while avoiding making billions of rows, right? Like, so if we have tract level data that's daily and we're attributing that to persons, that combination is just gonna be an explosion of data. So how can we use the tools without having that data at the person levels of an observation, or is that gonna be just a sacrifice we have to make? And just the development strategy for this optional module approach for integration with tools like Atlas, where people can sort of pick and choose whether or not they want to include this. And there's a lot of sites that this wouldn't be applicable to, but just being able to enable that and keep up to base with all the tools and software in the OHDSI stack. And we meet Mondays at 10 a.m. And if you have any questions, you can contact myself or Andrew. Thank you.